You are familiar with the importance of electric current in this modern world. I'm going to give an introduction to electric current in this video. You know that substances are made up of atoms. In atoms, at the center, there is a positively charged nucleus. Electrons are there in various orbits. In the case of metals, electrons in the outermost orbits are not bound to the nucleus. They can move about freely. Such electrons are called free electrons. Such substances are called conductors. So in the conductors, there will be large number of free electrons. Under ordinary temperature, these electrons can move at random, but that will not make current. You connect a battery across this. So there will be a potential difference. So you are familiar with the gravitational potential difference. You consider this pen on a surface. Now this is an equipotential surface. Potential here and here it is same. But when you lift it, this is at a higher potential and this is at a lower potential. So you can see this pen is moving from a higher potential to lower potential. Similarly, when you connect the conductor to a battery, there is a potential difference. So this positive, this end is negative. So these electrons will be attracted by this positive terminal. So electrons will be moving along this direction. So here a battery is connected at the two ends of a bulb. Now there will be a current. So battery is maintaining a potential difference. So for the flow of current, what's needed is a potential difference. Then electric current is defined as the rate of flow of charge across a given area. Current can be represented by the letter I. I is equal to Q by T. But the flow of charge is not always constant. So you consider a small interval delta T. Then amount of charge flowing during that small interval is delta Q. So average current is delta Q by delta T. Then you consider this limit delta T tends to 0 because this delta T is becoming smaller and smaller and it is tending to 0. Then according to calculus, delta Q by delta T, when delta T tends to 0, is dQ by dt. That is called instantaneous current. Instantaneous current I is equal to dQ by dt. If the rate of flow of charge is constant, it is I is equal to Q by T. Otherwise, I is equal to dQ by dt. Charge is measured in coulomb. Time is measured in second. Coulomb per second is known as ampere. So current is measured in ampere. Now let's find the current when a charge of 120 coulomb passes for a time of 2 minutes. We can substitute in this equation. Current I is equal to charge divided by time. Charge we can put 120. But here time is given in minutes. Before substituting in the equation, you have to convert it into seconds. So 2 into 60. After cancellation, it is 2 divided by 2 is 1. So current is 1 ampere. Now let us see the direction of the conventional current and what is conventional current. In a conductor, large number of free electrons are there. When there is no battery, these electrons are at random motion, that will not make current. When battery is connected at the two ends, then there is a potential difference. Under the influence of the potential difference, the electrons will be moving along this direction because electrons are negatively charged, that is attracted by the positive terminal. So electrons are moving this direction. But direction of the conventional current is from positive terminal to the negative terminal. So this is the direction of the conventional current. They took the direction of the conventional current as the direction of the positive charge. But later it was discovered actually what is flowing is electrons. Now electrons are flowing along this direction. So direction of the conventional current is opposite to the flow of electrons. Now you see this circuit. So this is the positive terminal and this is the negative terminal. So direction of the conventional current is from positive terminal to the negative terminal. But the flow of electron is from negative terminal to the positive terminal. So direction of the flow of the electron is opposite to the flow of the conventional current.